Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. We're talking conic sections and ellipses. Now this video is actually a problem set. Let's kind of do a very quick review of what an ellipse looks like and its properties. Remember, an ellipse is one of the four kinds of conic sections. So you slice through a cone here and you end up with kind of a squashed circle. Now, I mentioned in the video right before this that the general formula of the equation of a ellipse is this. Now it looks kind of complicated, but basically x and y are your variables, and a and b and h and k are actual constant numbers. All right, the h and the k part form the location of the center, and the a and the b part is the major axis and minor axis distances out from the center. All right, so it tells you how wide and how tall that ellipse is. So that's just a formula and equation that you'll have to remember, and then we look at it to be able to graph an ellipse. Now again, just kind of showing you a couple of quick examples that I had in a previous video, but you start with an equation and you locate the center and how wide and how tall the ellipse is, and then you can graph it. So look for that previous video if you need more of an explanation. Here's another example where it's been shifted to the left and then up, and you have to kind of do a little thing about here, the sign change. All right, but let's try a couple of problem sets, and I'm going to give you four altogether, and you can sketch this out on a piece of paper, but do try it first. So pause the video and see if you can figure out where the ellipse would go and what it would look like. Alright, if you've tried number one, notice it says x plus 2 right here. And in the equation formula for an ellipse, you have to have a subtraction value. So think of x take away negative 2. So the center is going to be at negative 2 and negative 4, because that would be y take away negative 4. Alright, so that's where you're going to locate your center. Negative 2, negative 4. You got to be careful of those signs. So back 2 on the x-axis and down 4. And that is where your center of the ellipse is going to be. Also, we have 16, which is actually 4 squared, right? And there's nothing here, but in order to create a denominator, because this will be our b value, think of it as y plus 4 quantity squared over 1, which is really 1 squared. So that means that the a value must be 4 and the b value must be 1. Alright, so that tells us how wide and how tall it is. So from the center, we're going to go 4 in each direction. So we're going to put a little spot right there, and 4 to the other direction. Alright, so your major axis is going to be 8 total, 4 in each direction from the center, and b is only going to go up 1, so you're going to have kind of a nice flat ellipse there, and it will look like this. And there it is. So you locate the center, and then you figure out how tall and how wide it is with the a and the b value. Now watch those signs. Now number 2, have you already tried it? If not, click on pause and give it a try. Alright, now notice that it says x squared here. Normally we would have an x minus h value, so h actually must be 0. And the y plus 2, remember we need to think of it as a subtraction there. And so our center actually is at 0, negative 2. Okay, it's already listed right here in our answer key. So there it is. There's the center. Make sure we locate that in the proper spot. Now 49, of course, is 7 squared, and 25 is 5 squared. And so we're going to go 7 in the right and the left directions and locate the vertex right there and right there. And that will be our major axis, total of 14. right there. And the minor axis is 10 because, of course, we're going 5 up and 5 down. All right, so I have our vertex right there and right there. All right, so once we have those 4 vertexes in the center, we can draw our ellipse. All right, 2 more to try. Numbers 3 and 4, give it a shot, and I'll wait for you, and then play the video to see if you're right. Number 3, x plus 1 means we need to rewrite it with a subtraction, right? So the h value is a -1, and the y value, or the k value is going to be 0. That's why the center has to be at -1, 0. Okay, be careful about that. And there it is. Back 1 from the origin. Okay, now the major axis is going to be 5 units in both directions because 25 is 5 squared, and a must be 5. 16 is 4 squared, so we have a minor axis total up and down of 4 in each direction, which is 8. Major axis 10, minor axis 8. So there are our 4 vertices, vertex in all 4 spots. Now we can draw our ellipse. I hope that you did well on that one. And number 4, finally, we have 3, x minus 3, x plus, or y plus 2. Let's rewrite that as x take away -2. And that's why our center is at +3, -2. So make sure you've shifted 3 right and 2 down. From there, we know that 9 is 3 squared. And 4 is 2 squared, kind of keeping it simple here. And so we go 3 in both directions to the right and left, 2 up and down, and our vertexes are located in those 4 spots. There is our ellipse. All right, now usually you can go a little more complicated than that. Basically, that's how you graph an ellipse. Thanks so much for watching this video, and we're going to move on to hyperbolas in the next pair of videos. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.